Okay, we're going to talk about sequential statements and how they actually relate to what's going on the board. First of all, I just want to demo what's happening here on the board. Essentially, this is very much like Lab 2. What I've done is I've just had a cylinder. My control statement is A plus, B plus, A minus, B minus. Nice and simple. So let's just run this. One press, that's all I have to do. It's so cool, I don't have to hold it down. The next thing. Now if I hold it down, it just keeps going. So this is called sequencing by position. So what happens here is that when A goes out, by the way, the thing that tells A to go out is kind of two things. One is the fact that that B has retracted and someone pressed the button. Yeah, so if this wasn't retracted and someone pressed the button, A wouldn't go out. And the reason is because the position of B is such that it's at home, and the limit valve, which is like a limit switch, is passing air. It's open because it's been activated. So this guy is at home and that's activated. There's pressurized air in here because we know, because it's a red hose. It's pressurized air in here, so therefore there is actually air coming out here. Let me actually do this. So, I didn't turn it off. So, there's air here because that's at home. Now what's going to happen is that when I press this, air is going to come out of here. It's going to move the spool in this, which is going to make the air from here come out this hose. So when this pilot activates the spool, it pushes the spool over, and then the air from here is coming out here. And then that makes the air go into the cylinder and makes it go out. When it goes out, this limit valve, which has air in it already, it has air supplied to it, it is not passing. But if I close it, it becomes passing. So right now, that is a closed valve. It's actually a normal closed valve. And when I activate it, it becomes open. Oh look, when it comes open, it then tells the spool in this DCV to move, and now air comes out here and it goes out there. Let me back up on that again. When this activates, it goes into its active state. It's a normally closed valve. It becomes open or passing. Now the air coming out of here it goes into the pilot of this DCV. It moves the spool inside the DCV. That spool makes air coming from supply, nice red hose, to come out this hose. So now the air is going to go into there and it's going to make this extend. When it extends, guess what? Yeah, it hits another limit valve. This limit valve is a normally closed valve. Normally, it's closed. When I activate it, it becomes open. The air, it's also got pressurized air. So actually, let's just take a look at this. Let's identify this on here. This guy is B plus. B plus is here. Okay, so it looks like the air that comes out of B plus goes into the action A minus. Let's take a look at that. So B plus goes into the limit valve that makes this cylinder retract. Let me put that there. Let's take a look at this. The air coming out of B plus goes into A minus. Now let's go on here to this section here. When A minus happens, this becomes passing. Remember, it's a normally closed valve, so it becomes open and air passes through it. The air coming out of here goes into that action. Let's take a look at that. A minus is right here. The air coming out of A minus, because you know what? We've got air supplied to A minus. So there's air right here supplied. The air coming out of A minus goes into B minus. That means the spooling here moves. The air that's in here already is going to come out here. It's going to make the cylinder retract. Makes sense? I think so. So let's continue on to this here, B minus. It looks like the limit valve, B minus. Yeah, the lower cases are for the limit valves. The upper cases are for the actions. The lowercase b minus, find it where it is, here it is. The lowercase b minus has air supplied to it. They don't always have air directly supplied to them, but that's okay. This guy has air coming in here. The air coming out of here goes to the push button. Goes to the push button. And then out of the push button, it goes to the action A+. Cool, eh? So this is a logical statement. It's like a programming language. You can make these really complicated to make all different kinds of actions happen. So if I have a control statement that's really complicated, I can actually use a sequential statement to just make the logic make sense, kind of program it, and then from there, it's just a hosing diagram. It's pretty cool. So, there you go. So now, as you know, in Lab 2, we have more complicated actions where some of these go out and back and forth at the same time. Let's take a look at what that looks like. So what this guy is doing is it's making A and B start to extend at the same time. Once they do their thing, once they both fully extend, then A retracts first and then B retracts. Now, I've put two sequential statements here. One is correct and one is not correct. And I want to show you why this is not correct. Let me just go over this just a little bit right now. We've got an AND situation. And we've talked about this in lecture, but this is how an AND thing works. Both A and B have to fully extend first, both of them, before A can retract. If A was a lot slower than B, let's say B got there really quickly, A and B, well, would both start at the same time, but they'd get out at different times. B would go really quickly, and then A would take a really long time to go for some reason. Once A was finally out, then A could retract. So what we do is we take the air going into A, and we bring it out, the limit valve A, and we bring it out and we power the limit valve B with the air coming out of A. That actually creates an AND, in that, let's say B got there first, and let's say we did it like this instead. We didn't do an AND, we just did a B straight to here, because if these go out at the same time, then they must not only start at the same time, but they must get to the end at the same time, right? Nope. Let's just say B was really quick and A was really slow. So if we did it like this, B would get out first, and before A even had a chance to fully extend, this guy would have fully extended, that would have been passing, air would have come out and made A retract. So that's not going to work, and I'll demo that. But right now, I'm going to demonstrate this, how it actually really works. Take a look. Oh, I can turn the air on. Let's do that again. So as you can see, A and B start to extend at the same time, and they're at the same speed actually. They get out at the same time. But that's just for this situation. And then you'll see A retract first. Watch for it. Now, I want to show you something that leads into conflict. There's actually some conflict in here, and we can deal with that with conflict resolution. But watch the conflict. it's not continuing. If I don't continue to press this button during 1/4 of the cycle, then it actually doesn't complete. So, but if I hold it until it gets there and then I let go, then it works. And that has to do with conflict, which we will talk about next. But just we'll hang on this actually for next week's lab. For lab 3, you're going to do conflict resolution. So you can think about that being just a small conflict. It actually goes way beyond that. This is a really basic conflict. What I've done now is I've made B go really quickly. And you'll see they start to go out at the same time, but B gets there really quickly. Right? So if we had done this, then that wouldn't have, this action never would have fully happened. Let's take a look at what that looks like. So I've taken A right out of the picture. There's nothing going on here. And if the cylinders move at the same time, it actually kind of works okay. It works okay. I mean, it seems to be working. That's because they both get out at the same time. Let's speed B up. I'm going to throttle this, so I'm actually going to counterclockwise this needle valve, this throttle valve. And now, A didn't even have a chance to get out. It went about that far before B got out all the way. Let's do it one more time. Good. Even if I hold it, it still doesn't work. Let's say that A was actually really quick and B was the slow poke. Let's see what happens then. So it's actually okay if A gets out really quickly because it's waiting for B anyway. But if B gets out first, then as we can see, A never actually goes out all the way. So it's important that we do an AND with our limit valves in that this guy and that guy both have to be passing. Yeah, for this to finally happen. Okay, so I think you're prepared to go ahead and build these yourself and do them on Automation Studio, and you'll see on Automation Studio that when you do them at the same time, when you do the brackets, they don't work as well, but you can actually slow everything down in Automation Studio as well. You might want to poke around with that and see how that happens, how that works, but that helps a little bit. Automation Studio really does catch the conflict. So if there is conflict in here, it really won't work very well. So your Automation Studio drawing really won't work well. If it's got a bracket in it, it's going to have conflict. The first one without a bracket, or any of them, with any of the other two in Lab 2, there's no conflict. But if you put a bracket, there's conflict, because the conflict is really when two actions happen right after each other that are pretty much opposite. Yeah, so if you had a sequential statement that was A plus, A minus, that creates a problem. And we'll talk about why that is true, but here we've got A plus happening and then A minus happening. Yeah, because there are brackets here. See, this happens and this happens at the same time, but essentially it's like this is happening and then this happens, and there's actually conflict there. And we saw that when this guy went out, but that guy wouldn't unless I held my finger on this button, actually past this until this became closed again. This wouldn't be able to open as long as I held my finger on that until this cylinder got to there. Then it actually got rid of the conflict. But I mean, there's another way to do that. That's not practical. We want to be able to just go press a button really quick and make it happen. So you are now prepared to go on and do Lab 2. Lab 2 is nice and basic and simple because there's no conflict in it. and I need you to hook up the board with the drawing that you did, or the drawing that I did that you guys are filling in with the hoses and stuff. So I think we're good to move on, and we'll unpack a lot more of this sequential statement in a lecture. Bye.